Should humanoids be ultra-bionic or ultra-robotic? Today on AI News, we're looking at a clash in robot design, and it all starts at the FIFA World Cup 2026, where Boston Dynamics and Hyundai just deployed Atlas to move in ways that no human ever could. But on the other side of the world, another company is taking the exact opposite approach. But we'll get into that right after we dive into Atlas, which just appeared at the World Cup, where Hyundai Motor Company integrated their humanoid into a live sporting event for the first time. Acting as the tournament's official robotics partner, Hyundai used the halftime slot to stage the first ever robotics activation in a live FIFA match environment, marking the official public debut of their production-grade Atlas. And during this activation, Atlas emerged from the player tunnel to showcase several football-inspired goal celebrations before delivering the ceremonial match ball to the referee to start off the second half of the game. In fact, to perform these fluid, full-body motions under real-world constraints, the engineering team relied on three distinct software systems, with the first being retargeting, which translates human anatomical movement and physical gestures directly into telemetry data that the robot's specific joint configurations can replicate. The second system uses reinforcement learning, where developers use thousands of computer simulations to train AI control models responsible for refining balance and error correction protocols before physical deployment. And the third system is whole-body control, which works using a centralized processing architecture that coordinates actuators across the entire chassis simultaneously, keeping Atlas balanced throughout its changing tasks. And looking into the future, this presentation ties into Hyundai's Next Starts Now campaign while building upon their School of Football digital media series, because in the pre-event content, engineers used the same training suite to teach Atlas special maneuvers like the Ghost Rabona kick. And to provide a technical breakdown of this preparation, Hyundai and BBC Storyworks will be releasing The Training Ground, which is a documentary-style ad feature detailing the engineering milestones behind Atlas's stadium deployment. But comment down below whether you'd prefer to rent or buy Atlas, and for how much. Plus, tell us whether you think superhuman robots will be most popular, or if you think people would rather have companions that are nearly indistinguishable from themselves, because an alternative design philosophy is emerging that instead focuses on mimicking human biology. This paradigm is represented by UBTECH's newest UWorld U1 series, introduced at their global launch event, with UBTECH positioning the platform as the world's first full-size ultra-bionic humanoid engineered specifically for mass production. In fact, to achieve the most lifelike form factor, the U1 features proprietary biomimetic skin and 88 degrees of freedom throughout its body, with its mechanical design incorporating a dual-pivot biomimetic cervical spine, allowing it to accurately reproduce up to 90% of fundamental human movements. Furthermore, unlike the high-velocity, superhuman agility seen in industrial platforms like Atlas, the U1 instead restricts its physical form to match standard human mobility constraints. And when it comes to artificial intelligence, the core processing framework relies on a biomimetic fast and slow brain architecture, which is a dual-layer system that pairs rapid, intuitive responses with deep reasoning capabilities. This generates basic contextual reactions within approximately 500 milliseconds. Then, for complex decision-making, the robot uses onboard AI models with hundreds of billions of parameters. On top of this, for interpersonal interaction, the U1 platform runs an emotion-aware large language model designed to identify more than 20 fine-grained emotional states with an accuracy rate exceeding 90%. And to simulate natural communication, U1's facial expression actuation system synchronizes spoken text with lip movements within a 20 millisecond latency threshold, with long-term interactions being logged via Agent Memory OS, which establishes a cross-temporal memory framework so the U1 retains information across multiple encounters. Finally, data security is managed through a three-layer privacy architecture. This protocol prioritizes local-first computing on the robot's hardware, minimizes reliance on cloud servers, and incorporates physical, user-controlled hardware protections to secure user data. At the same time, AGIB just introduced its brand new A3 robot, and they're leaning towards performance with their standout feature being the A3's power-to-weight ratio. While it weighs only 55 kilograms or about 121 pounds, Because of its magnesium titanium alloy frame and flexible TPU materials, the A3 pushes out 12 kilowatts of power, which translates to a 0.218 kilowatt to kilogram power to weight ratio. But what really catches the eye isn't just the acrobatics, it's also the power management, because the A3 packs a 1152 watt-hour dual battery system using full-tab cell tech, giving it a maximum runtime of 10 hours. More importantly though, it also features a redundant, hot swappable battery setup, allowing users to swap out the packs in about 10 seconds flat without powering down the robot. Plus, the A3 is built for scale and customization, with the developers having clearly designed the robot to be highly deployable. And for the robot's interface, instead of relying strictly on voice commands, the A3 introduces an industry-first shoulder touching sensing feature to make human interaction more natural. But comment down below how much you think the A3 should cost. Simultaneously, humanoids may have just left the arms on wheels era, as Exhumanoid just unveiled TG-VLA, a new framework that represents the first full-size whole-body vision language action system built specifically for humanoid robots. For years, humanoid demos have suffered from a glaring design bottleneck. They're overwhelmingly arm-centric. In typical tasks, the upper body handles the cognitive heavy lifting by seeing, planning, and grasping, while the legs serve as little more than a motorized tripod to transport the limbs. But TGVLA dismantles this separation by merging locomotion, torso stability, balance, and manipulation into a single unified control loop. And in a legendary demonstration of agentic AI engineering, a classic 2003 PC game has been successfully ported to iOS in just a couple days by the lead product designer at Google AI Studio, who brought Command & Conquer General Zero Hour to iPhones and iPads. Incredibly, it was accomplished with Anthropic's Claude code running on its latest Fable 5 model, and rather than using clunky emulation, the game runs natively on ARM64 architecture, with Fable 5 handling the heavy lifting of rewriting a legacy graphics pipeline and translating ancient DirectX 8 code into Apple's modern Metal API through several intermediate steps. It's also reported that compiling the initial functional build took just 40 minutes, followed by a few hours of collaborative debugging with Fable 5. And over the intense 2-day period, the lead product designer of Google AI Studio exhausted his entire Fable 5 token quota refining the project, with the final result supporting native touch controls across the campaign, skirmishes, and special challenges, and the full source code has been shared on GitHub. But importantly, because original game assets are omitted for copyright compliance, players must supply their own files from legal copies to play it. Anyways, like and subscribe and check out this video here for more on the latest in AI news, and thanks for watching.